Hello everyone, let's learn about relational algebra in DBMS. What is relational algebra? In relational algebra, queries are composed using a collection of operators, and each query describes a step-by-step procedure for computing the described answer. That is, queries are specified in an operational manner. Let's get deeper. Here comes the first operator, selection, denoted by sigma. It specifies the tuples to retain through selection condition. That means it gives rows as the output based on a specific condition. It selects the rows that satisfy a given condition. For example, let's consider three tables, that is sailors, reserves and boats, having attributes. For sailors, it is SID as the primary key, SName, rating and age. For reserves, it is SID, BID, day, and boats, it's PID, BName and color. BID is the primary key. Let's see how selection operation works. Example Q&As for selection. Let's see a question to understand more about selection operator. Display all the sailors of rating above 8. So how do you write a query for this, and how do you get an output for given the question? Let's see. Query. So as I already said, it is denoted by the symbol sigma, and you write a specific condition on what you have to get the output for. Sigma of sailors. On condition in the question, it is mentioned that rating above 8. So you write the condition below the sailors. Overall, sigma for sailors for condition rating greater than 8. You get an output of table with SID, SName, rating, age. These are the sailors which are having rating above 8. Next, projection, the second operator. It allows us to extract columns from a relation. So it is denoted by symbol sigma pi. It selects specific columns. For example, we'll see some example Q&As for this. Display name and rating for all the sailors. So for the query is pi of sailors with SName and rating. As in the question they mentioned to display name and rating of all the sailors. So what you want to get in your output as an attribute, so you just mention it below the sailors, SName and rating, and overall pi for the condition. So you get a table as an output displaying SName and rating. So Dustin, Lubber, Rusty, Yuppie with rating 7, 8, 9, 10, 9 gives as an output for the projection. For the given question, more example Q&As to understand more about projection. Display the name of the boat of red color. With query, you want all the name of the boats which are having red color. So you write outside the bracket pi with B name, and inside the bracket with sigma color, and you write the condition that color is that you want is red in boats table. So the output will be displayed as a B name with B name is displayed as an output, and the name of the boat is displayed with the red color, that is marine. I hope you understood. So the note is that relational algebra assumes no duplicates in the output, so you don't get the repeated values in your tables. So it assumes that no duplicates are allowed in the relational algebra. the next operator, set manipulation operators. So the following standard operators also available on relational algebra. They are union, intersection, set difference. Set manipulation operators has some rules to follow. So they are union, intersection, set difference is allowed between two compatible relation instances. The two relation instances are said to be compatible if the following conditions hold. So as I told, they have some conditions to be followed. They should have same number of attributes, and the corresponding attributes taken in the order from left to right must have the same domain name. That means they should be in the same domain name. That if a record from the table 1 is having int as domain name, the next table should also have the same domain name as int, so that set manipulation operators can be used. It can be from any order. For example, the question is given that find all the sailors of rating greater than or equal to 9, or all the sailors whose rating less than or equal to 9, or both. So here you use union operator. Let's see how it is used. So the query is, the question is asked about the sailors who have rating greater than or equal to 9. So the first condition is given about the sailors rating is greater than or equal to 9, whereas, and again they are asking about sailors whose rating less than or equal to 9, or both. So back then there was a mistake here, it's less than. So the second condition is about it is less than 9 or equal to 9. So second condition is also specified in the query. As they are asking about both, you use an union operator, and the output we get a table with SID, SName, rating and age. Here you can see that the rating column, which specifies rating is greater than or equal to 9, or less than or equal to 9, the sailors are displayed, all the sailors. Next, another example, Q&A. So find all the sailors of rating greater than or equal to 9, and all the sailors with rating less than or equal to 9. The query will tell you about the first condition. We'll write the query sigma sailors of rating that is greater than or equal to 9, and sailors with rating less than or equal to 9. The second condition, here the same mistake actually, I'm sorry. So it is less than, yeah. So you combine both the conditions with intersection symbol, intersection operator here between them. So you get an output with SID, SName, rating, age. As here they mentioned, and all the sailors with rating less than or equal to 9. Here itself it tells that we should use the intersection operator. So we get an output SID, SName, rating, age, with SName UP of SID 28 with rating 9 and age 35. Next, another example for set difference. Find all the sailors of rating greater than or equal to 9, but not sailors with rating less than or equal to 9. So we write the first condition specifies about the rating greater than or equal to 9, rating greater than or equal to 9, but not sailors with rating less than or equal to 9. The sigma sailors rating less than or equal to 9. So we use sigma for two conditions, and here it specifies that but not the sailors within rating less than or equal to 9. We have the sailors for rating greater than or equal to 9, but we should not, and it is not needed with the sailors with rating less than or equal to 9. So we use a set difference operator. So we use this to get the output SID with S name, rating, age, Rusty with SID 58 and rating 10 and 35. So for your information, I just want to tell you that to understand more about this set manipulation operators, actually there's a trick to specify these set manipulation operators. If we go to the union operator, you get to see that they used OR as a word here to join two conditions. So we use a union operator when two sets or both, like R or S or both. Let's consider the first condition as R and second condition as S and third condition as both. So R union S or both. So here it is a trick that if you get two conditions between them or as a word, so you can use union operator. And also for intersection, you already know that we use AND. So let's consider the first condition as R and the second condition as S. So between them you are joining the word add. So here that means if you see a word and between two conditions, you can use intersection operator for the given conditions to get the output. So it is a trick that you can easily identify. You can use that intersection operator. Next, for set difference, as I already told you, but not is a word that joins two conditions. Here if you see a word with but not between two conditions, like first condition is R and second condition is S, just consider them, and between them you are seeing a two words, that is but not. So you should use set difference as operator between two conditions to get the required output. So these are some tricks you can identify which operator to use between the conditions to get desired output. I hope you understand what I am telling you. Next, cross product, which is also known as Cartesian product, denoted with cross symbol. R cross S returns a relation instance whose schema contains all the fields of R followed by all the fields of S. The result of R cross S contains one tuple R comma S for each pair of small r belongs to capital R and small s belongs to capital S. Let's consider a table R with A and B as columns and values 1, 2, 3, 4, and another table S with C and D as columns with values 5, 6, 7, 8. Let's just do the Cartesian product of R and S, R cross S. The columns are joined and the number of columns are joined. If you have two columns in table R and if you have two columns in table S, they are just joined and will give you the result in R cross S. So the Cartesian product is done, as you know how it is done. The first tuple is multiplied with 5, 6 and again 1, 2 with 7, 8 mapped. So 3, 4 are mapped with 5, 6 and again 3, 4 are mapped with 7, 8. See, as how I told in the individual tables, in the desired table you can see that 1, 2, 5, 6, 1, 2, 7, 8, 3, 4, 5, 6 and 3, 4, 7, 8. Cross product. For example, find the name of the sailors who reserved a boat with BID 103. So the query, so pi S name, you want the names of the sailor, so you just write the pi with condition S name. So inside the bracket they asked about sailors who reserved a boat with boat ID 103. So sailors and reserves have a common attribute, that is SID. To join them, we have to write the common condition, that is sailors.sid is equals to reserve.sid. So, and you use a operator here to join conditions. So BID with 103, that is also a condition, and cross producting the sailors and reserves to get the output of what we need. Names of the sailors who reserved a boat with BID 103. Let's see who reserved the boats. Dustin and Lubber are the people who reserved a boat with BID 103. Next, join. And this is the join symbol with condition C. It is defined as cross product followed by selection and then projection. So R join S is equal to sigma of R cross S. For example, find the name of the sailor who reserved a boat with BID is equals to 103. Pi S name, as you want the name of the sailor, so pi S name, and all the sailors who have reserved a boat with BID 103, that comes out, and the sailor joins reserves with condition sailors ID is equals to reserves S dot ID. Sailors join with condition, the common condition in between, that is sailors dot SID is equals to reserves dot SID. So sailors join reserves with common condition, that is sailors dot SID is equals to reserves dot SID. The output is Dustin and Lubber. First you select and then project to get the desired output. Next, natural join, in which join condition is by default equality condition on all the attributes having the same name. That means natural join is used as a join. By default we get the common conditions, like as we observed sailors.sid is equals to reserves.sid. Here we don't have to mention anything. Itself, the natural join itself, by defaultly the equality condition comes on all the attributes. So let's see an example to understand this. Find BID of the boats reserved by sailor Rusty. So pi, you want BID of the boats reserved by the sailor Rusty. So pi BID of sigma, you select sailors with S name Rusty, and now you join sailors and reserves. The common conditions are already comes with natural join, so you don't have to mention any common condition between them. You get the output BID 102. Division. Consider two relations A and B, in which A has exactly two fields x and y and B has one field y with the same domain as in A. We define division operation A divided B as a set of all x values such that for every y value in B there is a tuple in A. For example, let's consider a table with columns x and y having values x1, 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 x2, 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 x3, y1, y2, y3, y1, y2, y3, y1, and another table B1 A and another table B2 with only one column, that is y. As I mentioned, B has one field, that is y. So we are taking two B tables, that is B1 and B2 with one column, one attribute, that is y. So if we divide A with B1, A divided B1, we get the set of all values x. Like here we have y1, y2, y3, and also in the table y1, y2, y3. So the common value for these y1, y2, y3 is displayed in A divided B1 table, that is x1. A divided by B2. Let's see. Here the output we got as x1, x2. Here for y1 and y2, yes, here we are having y1 and y2, x2, x2, and here also we are having y1 and y2. We are having x1 and x1 for the respective y1 and y2 values. So if we divide A with B2, we get common values of x as x1 and x2. Example, find sailor name who reserves all the boats. Now, the whole query, you can see that by S name and BID, as they asked sailor name who reserved all the boats. So you have to project S name with BID. Sailor, we get sailor's name and reserve who reserves all the boats by joining the sailors table and reserves table. So we use join between them, natural join between them. So sailors and reserves, as you want sailor's name with who reserves all the boats, so you have to know that which sailor has reserved which boat. So you want to display S name and BID by using projection. So divided by I BID of boats. Here we get the common values like output with S name, that is Dustin. Thank you. Hope you people understand about relational algebra. Thank you for watching this video.